Okay, Trig, this is the first half of section 10.5. We did skip section 10.4, so if you're looking for where that is, we skipped it. We just did 10.3, and I'm going to give you an example of some stuff that we did in 10.3 just to kind of regroup and move on to build on that to what is new. So we talked about in section 10.3 something called rectangular form. And I'll give you an example of rectangular form when we'll do this problem. So rectangular form was something like -3 minus 4i. Let's do that problem, okay? And then we switched between rectangular form and something called polar form. And polar form looks like this. So we're actually going to switch this really quick. So r, and then we have cosine of theta plus I sine of theta, okay? And so switching from rectangular form to polar form, you don't have to graph it, but it's easier if you do. So -3 minus 4i, this is your x-coordinate, and this is your y-coordinate, in a sense, kind of. And we do -3 minus 4. 1, 2, 3, 4. There we go. And we connect them back, and we make a bow tie, not an hourglass, and we do our angle thetas here, and this is -3, and this is -4. I'm going through this kind of fast because we've done this already, but one thing that we need to find is this, and that is the hypotenuse. So we do that by doing the Pythagorean theorem, or we can just know that this is a 3, 4, 5 right triangle, and we leave that as 5. Just FYI, this hypotenuse will never be negative. I know I've said that before when we've done these, but your hypotenuse will never be negative because in the Pythagorean theorem, it switches and squares the negative to make it positive. So we have 5, and 5 is r. So 5 goes in this spot. And now all we have left to find is what our angle theta is, okay? And so we can look at this triangle, and angle theta is this angle here, and we're trying to find that. We can use sine, cosine, tangent, whichever one, but I usually just stick with what they gave me originally to start with. And -4 is the opposite, and -3 is the adjacent. So I'm going to do tangent of angle theta, and opposite over adjacent is -4 over -3, which means to solve for theta, we have to do the inverse tangent. And I'm going to cross those negatives out so it's less for me to type in. I can just reduce those. And our angle theta is going to be the inverse tangent of 4/3, which, give me a second, 4/3. And inverse tangent, and that is 53. We'll go 53.1 degrees, and that is how that works. So I'm going to write this because I didn't leave very much room. 5 times cosine of 53.1 plus I times sine of 53.1. Now, the other day I told you that a way that you can check your answer is you can take 5 and multiply that by cosine of 53.1, and you should get something close to -3. It might not be exactly because 53.1 was rounded, but you can multiply those through and check your answer to get -3. If you take 5 times sine of 53.1, you should get something close to -4, and that's a way of checking your answer. So going from rectangular form to polar form and back should be fairly easy, okay? The one direction is a little bit harder just because you have to map it out and do that. But, you know, that's that. We're going to introduce one more thing in this section, and it's a different form, and it is called, I'm going to put it off to the side over here. This is called component form, okay? And it's really similar to rectangular form, the easy one, except it uses like these triangle brackets rather than using parentheses, and this would be -3 comma -4. So it's very, very similar to this, but component form is just in triangular brackets, and it's just kind of doing your x and y coordinates from there, okay? So we have component form, rectangular form, and polar form. Those are the 3 that we're going to be switching between, okay? All right, so component form, this is the notation that we use for vectors, okay? So we use the triangular brackets to talk about vectors in a plane, and I said that like vectors are going to be similar to like projectiles. So if I'm throwing a ball or launching something out of a t-shirt gun, I would start at this point and it would launch this direction and it would go to Q, and this vector does have an arrow on it so that I know I'm starting here an ending here for my vector, and that's the angle that I'm shooting that at, okay? This one is also a vector, but they've named it a little bit differently. This one that's going straight up, so I'm launching something like straight up in the air, and rather than having 2 points on the end of those, at the beginning and the end, they named it by calling it vector U, but vectors have like a bold face on the side of it. So it's kind of like when we say all reals and we do the bold face, vectors are lowercase letters and they have like a little bolded edge. This is vector V, it's going this direction. V is this vector and there's a bold edge on it. This is vector W, and we have W with a bold edge on it, okay? If we're going to actually write out the name of this vector, this would be vector PQ with an arrow over top of it, okay? Yeah, kind of like you have like ray PQ, okay? So your initial point, which is your starting point, would be P, and your terminal point would be Q. That's where it like ends, basically, your vector ends, okay? All right, so let's talk about something called equivalent vectors, and you have 2 important measurements for vectors. The first measurement is something called the magnitude, and this is like the force, or sometimes they'll use like velocity. This is the like force or the speed that I'm throwing the thing that I'm throwing, right? So if I'm throwing a ball, it's going to be the velocity that I launch that ball with. That is the magnitude. And the magnitude a lot of times will be represented in length. So it's like how long your vector is, right? So like this vector is that length, this vector is this length. So this one I'm probably using more force than this one, okay? So it just has to do with the length of your vector. That's the force. And then the direction. So like this direction is maybe going at a like 45-degree angle with the horizontal. This direction might be like a 260-degree angle or something like that, whatever. We'll talk about those later on, but it's just like where it's going. This one's pointing toward the first quadrant, so it's going to be an angle in the first quadrant. This is in the third quadrant, so that's why I said like a 260-degree angle, because that would be the third quadrant, okay? Vectors are only equivalent if those 2 things are the same, your magnitude and your direction, okay? So like this vector is equivalent to this one because they are going exactly in the same direction and they're the same length, so magnitude, direction. These 2 have the same magnitude. They're exactly the same length, but they're going opposite directions, so not equivalent. These 2 are going the same direction, but they are not the same length, so their magnitude is not the same. And these, neither one has the same magnitude or the same direction. So the only equivalent vectors here would be those first 2, okay? Now, when we're talking about magnitude, okay, I'm going to go back up to this top here. If this guy was a vector, and it was like represented with -3, -4, or in component form, -3, -4. If this was a vector and we were trying to find the magnitude, we're trying to find the length, that's exactly like finding that R value, right? You do the Pythagorean theorem, and that will give you your magnitude or your R, okay? So we've already done this before, actually. Magnitude, I'm just going to say, is length, GTH, and it's kind of like the R value that we find in our polar form. So you use the Pythagorean theorem, or take the square root of a squared plus b squared, okay? First thing I'm going to do with this is I'm going to talk about component form, and we're doing vector PQ, okay? So if I'm doing component form of PQ, I would first write PQ with an arrow, and I would say equals to, and component form, if they give me the starting point and the ending point, is just going from like, this is your starting point and this is your ending point. So if I'm going from 1 to 5, I'm going to the right 4 units, right? And if I'm going from 2 to 4, I'm going up 2 units, right? So vector PQ would be 4, 2, right? Okay. And then, so to find the magnitude of that, I would do like 4 squared plus 2 squared equals c squared. And I would take the square root of that, whatever that is, right? 16, 4, this would be a square root of 20 for a magnitude, right? Okay. Now, if I do from O to R, okay, O is at 0, 0, R is at 4, 2. So from 0 to 4, it's going to the right 4 also. From 0 to 2, it's going up 2, right? So OR is the same as vector PQ because they're both 4 2s. Okay, they have the same magnitude, they're going the same direction, all that good stuff. Okay, 4 2. Okay, versus like let's say we had a I'm not going to get into that. So those have the same component form, so they have the same magnitude, same direction. We'll just leave it at that, okay? So example 2, find the components and the magnitude. So that's component form, just like we just got into doing, and the magnitude. We just did this example, right? We're starting at P and going to Q. So PQ's component form is, I do those little triangular brackets. I don't know what those things are called. We're starting at -2 and we're going to 4. So that's like increasing 6, right? Another way of thinking about it is like x2 minus x1. This is your second x coordinate. This is your first x coordinate. So if you need to do 4 minus a -2, that will give you 6, right? That's just a way of thinking about it, okay? And then the second one is -3 and 6. So I'm starting at 6, which is up 6, and I'm going down to -3. That's down 9, okay? Or if you need to do y2 minus y1, you can do that. You would start with -3 and subtract 6, right? -3 minus 6 is -9. So that is your component form. And then if I'm trying to find the magnitude, okay, 6 -9 would be 1, 2, 3, 4, 5, 6, -9, whatever, all the way down here, right? 6 -9. To find the magnitude, you're just going to do the Pythagorean theorem. So 6 squared plus -9 squared equals c squared, okay? And we're going to take the square root of that. This is 36. This is 81. And so your c is going to be the square root of 117. And if it doesn't come out nicely, we just leave it as 117, the square root of 117. That is your magnitude. So we did component form and we did magnitude, okay? If I'm going too fast, make sure you pause and regroup, okay? All right, and is that all I want to do? Maybe that's all I want to do for today. Maybe that's all I want to do. Let me go back to your homework assignment. Yes, that's all I want to do for today, I think. You should be able to do 1 through 4, so do that for homework, and also do 9 through 11, and yeah, let's just do that. So 1 through 4 and 9 through 11, just do those 7 problems for homework, okay? And then I will finish the second half of 10-5 notes for tomorrow, okay?